All artificial intelligence tools are based on mathematical statistics and probability. Let's explore this world with an interactive way in our favorite programming language, Python. To kick things off, we'll clarify what's the difference between probability and statistics. Probability is the chance that a given event will occur. That means probability will be number between 0 and 1. 0 is when event will never happen, and 1 is when event will happen every time. Statistics is the way how to manipulate, analyze, and draw conclusion from data. Statistics is generally used when you have lots of data, big data sets, and you want to make some operation over the data. In today's tutorial, I will teach you basic probability throughout Monte Carlo pi approximation. You probably know that probability of a basic event is defined as a number of suitable events that we want and number of all possible events that have some sense. You don't want to include all the events like sun will explode or something like that. Only the events that make sense. What is Monte Carlo pi approximation? It will be our exercise when the suitable events will be points in the circle, in the unit circle, and all events will be points in the unit square. And the result will be some probability, and it will approximate the pi, because the area of circle is counted p multiplied by radius to the power of 2, and area of square of our unit square will be defined as radius multiplied by radius and multiply by 4. If we get rid of the radiuses, we will get pi over 4, and if we multiply whole formula with number 4, we will get 4 times area of circle over area of square, and the result will be pi. Just remember, as I said, the basic probability is done when we divide our suitable events over all events, and we will get number between 0 and 1. Let's move to the code. As a starting point, I will import module random, and I will define the Monte Carlo pi function that will iterate over our samples and provide the result how many points are in the circle. Then we will put this number into final formula and print out the probability of this event. So let me define the function named Monte Carlo pi. It will take one parameter, which is number of samples. For every sample in our number of samples, we will generate a random value on the x-axis and y-axis, and we will use Pythagoras theorem to count if it's in the unit circle or if it's in the unit square only. It is done by basic for loop, and the x value will be random. The random function from module random will generate number from 0 to 1. Also the same thing from the y value. And now in the same for loop through the Pythagoras theorem, like this, x to the power of 2 plus y to the power of 2 is less or equal to 1. So it is inside the circle. We will make some variable inside the circle. Initialize that variable, and for every occurrence inside the circle we will add 1. Quick tip: you don't want to have magic variables in your program. I will define global variable named unit circle. It will be which will be 1, and alter our code to be more readable. So now we have this Pythagoras theorem, and if it is in unit circle, I will add 1 to the inside the circle. Now I will return, not capital letters, return the variable inside the circle, define our sample size to number of 10,000. You can change it whenever you want, and assign our variable from function Monte Carlo pi into inside the circle. I don't wanna call it the same name. I will just define variable inside and assign the value from the Monte Carlo function pi with the number of samples. As the last thing, I will calculate the probability of the points being inside over the points being outside the circle, multiply by 4. It will give us the result we wanted, and it should be close to the pi. So estimated pi will be our inside values over all values multiply by 4, and let me print this out through the f-string. So our final probability will be estimated pi is estimated pi. Let's save this, run the code, and as you can see 3.1164 is our probability of the points being in the circle over the all points we have. That's the main thing you need to remember from this tutorial. And we multiply this number with 4 as I showed you before, and we got our estimated p. Once again, it is a bit closer now. I hope you enjoyed this tutorial. Thanks for watching, like, subscribe, and have a nice day. Peace.